Thank you, Ken. I can't offer anything that will top what we've heard so far. And I explained by disclaimer that this was the length, breadth, and depth of my knowledge of the subject and a little bit of background. I had the pleasure as an undergraduate of being able to minor in general science. And that's after I flunked organic chemistry twice and decided chemistry wasn't in my future. And my advisor as a minor was a Cornell graduate. He had gotten his PhD at Cornell, Dr. John Bailey, in the 50s. And he introduced me to the concept of freedom with responsibility and asked me with a general science minor what subjects interested me. Well, gee, I said, I have a range of interests, maybe meteorology, maybe physical geography, photography, geology. He said, well, put those all together and we'll call that your minor in general science. And that was my introduction in physical geography to how the seasons happen. And it also introduced me to meteorology. And I found both of them very enjoyable in my lifetime. I've used them occasionally in my profession, but more often than not, just for personal enjoyment. So I'm going to do some screen sharing here, I hope. And let's do this. And so there should be on the screen a title slide. I hope that's the way it is.
You got it.
You got it.
This is with apologies to the serialized TV show also, which I have not watched, I've just heard about. And also, this is not any photography of my own. I haven't had a chance to get on any of the space shuttles yet or anything like that, nor am I inclined to think about it. So today is a significant day. At 5:14 a.m. this morning, as I was getting ready to start some of my field surveys, the summer began, the summer solstice. And there is some terminology that's relevant. Rotation is the turning of the Earth upon its axis. A little more obscure, revolution, the movement of the Earth around the sun. Plane of the ecliptic is even more obscure. It's the imaginary plane defined by the orbit of the Earth around the sun, which raised in my mind, what is an ecliptic? Well, it's the circle representing the sun's apparent path during the year, called because lunar and solar eclipses can occur only when the sun crosses the ecliptic. And that's from Google's English Dictionary online. Quite important is the tilt of the sun relative to the plane of the ecliptic, or the tilt of the Earth, I'm sorry, relative to the plane of the ecliptic. And the 23.5 degrees is the inclination of the axis of the Earth relative to the plane. Solstice, from Latin, the sun, and to stand still. The point where the sun appears to reach either its highest or lowest point in the sky for the year. And in that case, ancient astronomers came to know the day as one where the sun appeared to stand still, and it may have been an important consideration in the creation of the Stonehenge in southwest England. And equinox. It's the time at which a planet's subsolar point passes through its equator. The equinox is the only time when both the northern and the southern hemispheres experience roughly equal amounts of daytime and nighttime. So that gives you some background information, I think, that got my attention anyway when I started thinking about what these things meant and how much or how little I knew about them. So this is very relevant to thinking about the seasons. If the sun weren't 23.5 degrees off 90 degrees relevant to the plane of the ecliptic, we wouldn't have seasons, I don't think, or we wouldn't have anything that appears like today's seasons. So that 23.5 degrees is an important consideration. And that's because of the northern hemisphere events. Now, vernal equinox, the spring equinox, orientation of the Earth relative to the sun is such that the sun is overhead at the equator. 21st March. Day and night are of equal length at that point. The summer solstice, orientation of the Earth relative to the sun, so that the sun is overhead at the Tropic of Cancer. And if you have difficulty remembering where the two tropics are, Tropic of Cancer and Tropic of Capricorn, think of the north to south as being in alphabetical order. Cancer comes before Capricorn. Around the 21st of June, the longest length of daylight and the shortest night, which is what we're experiencing today. Then the autumnal equinox, orientation of the Earth relative to the sun is such that the sun is overhead at the equator again. That's about the 23rd of September, and day and night again are of equal length. And then the winter solstice, as we're dealing with the tilt of the Earth throughout the seasons, the Earth relative to the sun is such that the sun is overhead at the Tropic of Capricorn, 22nd of December, and again, the shortest length of daylight and the longest night. So all of the seasons are related to the tilt of the Earth and its position in its orbit relative to the sun. And I'll try to use some graphics here. So here's one explanation, or one graphic showing the rays of the sun falling directly at the equator during the vernal equinox. The Earth is revolving about the sun. So at the summer solstice, the sun is overhead at the Tropic of Cancer. We continue with the march of the seasons. The autumnal equinox, sun is again overhead at the equator, and then the winter solstice. And these are all with relevance to the northern hemisphere. Sun overhead at the Tropic of Capricorn. So that's what's going on. Here's another way of looking at it with the 23.5 degree tilt shown more clearly, I think. Autumnal, winter, vernal, and summer in that sequence. We should actually start with summer solstice and rotate counterclockwise there. And the dates in this graphic, which came from the web, are the first full days of the resulting season. So March 20th is the date that the vernal equinox happens, not necessarily at the beginning of that date. June 22nd, again, that's tomorrow, the first full day of the summer solstice, and so on. And here's a visual representation that I think is just a little bit fast, but shows pretty much what happens. The tilt of the Earth doesn't change. Its position relative to the sun is what does, and that brings us our seasons. And so that's all I have to say. That's the length, breadth, and depth. Too bad Mark's not here. He could probably add to it. And I can take a few questions right now, and we can think about it.
Okay, my first question is, when did the Earth tilt?
I have no idea, but I would imagine it's a few hundred million years ago, possibly as a result of being hit by a larger asteroid than the one that killed all the dinosaurs. But I don't really know. I haven't seen it speculated.
And I wonder, are the other planets also tilted, or are we the only one?
The others have their orientation to the sun is not at 90 degrees, and they're not at 23.5 degrees. So the others perhaps have experienced different celestial histories, but I just know from reading about it and hearing about it that the other planets have positions relative to the sun that's not at 90 degrees to the plane of the ecliptic for that planet. And as a result, they have seasons, it's thought, not so benign as ours, but definite seasons of change.
Interestingly, the axis of the Earth rotates a little bit, and that...
Yeah, there's wobble. The Earth wobbles a little bit about its axis. I don't remember how many degrees it's expected, but that causes some seasonal variation, though it's, I sense nothing compared to what we're experiencing now in the context of climate change.
Well, it's also responsible for the glacial periods.
Yes, that's what's thought presently right now.
Why didn't the Earth return to its original axis after being impacted by an asteroid?
I would imagine there's some gravitational effects involved, and perhaps there just wasn't a way, there wasn't a way in which the Earth could return to 90 degrees relative to the sun, assuming that it originally was 90 degrees relative to the sun. We don't really know that, or I don't.
Yes, it's rather like a gyroscope. If you push that to the side, it retains that position.
Yeah.
tilted axis of Earth?
Sorry? Was that a question or an observation? I missed it.
Kurt was talking to us.
I was Googling.
Oh, good.
Something big hit Earth and knocked it off kilter.
Yeah, that's what I had heard or read. Yes.
The big thing
Bigger than the asteroid that killed the dinosaurs, I imagine.
is the whatever hit the Earth that caused it is called Theia, Theia.
Oh, okay. How long ago does it say, Kurt?
It does not in my initial thing here, but
It was before COVID.
Yes, so far as we know.
here we
BC,
go.
right?
A Mars-sized planet
Oh,
about 4.5 billion years ago that nearly vaporized them both.
wow.
And that's what knocked debris into orbit to form the moon.
Yes, okay, that much I know.
Okay.
Fascinating.
Isn't the Earth
How
just
long ago?
4.5 billion years old? I think that's as old as the Earth is, isn't it?
That's when life started.
4.5 billion?
They might have come from that debris.
There you go.
Who
That may have
knows?
stirred up some organic chemicals.
Yeah. A bit of
You're
trivia, and most of us know who James Watson and Francis Crick, in one case were, in another case are. James Watson still lives. Francis Crick published a little article in, I think, American Scientist back in the 60s called Directed Panspermia, wherein he proposed that life on Earth began as the arrival of a galactic object with the right chemicals on it or the right organisms on it to start life. And that's been rejuvenated recently. And I don't remember seeing credit given to Francis Crick for the observation, but even when I read it as a graduate student, I found that sounded a lot more plausible than other things at the time, but that was still in the 70s.
But of course, if life came from the object hitting Earth, how did life start on that object?
Good question.
I mean, I find these theories unnecessary.
Oh, I do
Because
too.
you've got to start it somewhere, so you might as well start it here.
They keep a lot of cosmologists and astronomers employed, but my understanding of these things is very simple. Space is infinite in all directions and time is infinite in two directions, and that's all I need to know.
The most credible
Why
explanation
complicate
I've
things?
read for the most credible explanation I've read for organic life starting on Earth is the energy generated by volcanic jets deep in the ocean, forming sulfur-containing organic compounds that eventually coalesced with some lipid membrane structures. And they're pretty good theoretical explanation that sounds very credible as far as a possibility.
Mm-hmm. Yes.
And what I've got here is there's they even put a name on the event of a proto-Earth colliding with a Mars-sized planet 4.5 billion years ago. It's called the Big Whack. I'm not making this up.
Cosmologists have a sense of humor, I think.
Yes.
Yes, you almost have to study those kinds of things.
If I could add some physics of dynamics, and that is that Peter mentioned the spinning top. So basically the Earth is carrying a certain amount of angular momentum.
Yeah.
And angular momentum has two aspects of it. One is the magnitude and one is the vector direction. And it is very difficult to change angular momentum in a system like we're in, because all the gravitational forces between the planets and the sun are generally through the center of mass. And the center forces through the center of mass do not create any torques. And it's the torques that are required to change the angular momentum, at least the direction of the angular momentum. So certainly if there was an impact that was tangential or off center of another object with then young Earth, you probably could change its angular momentum. And so basically it's the principle of angular momentum in which the direction and the magnitude of both parts of the quantity remains basically constant and very difficult to change over billions of years. So that's the physics of it. It's
Great.
much like a spinning top.
Thank you. That's fascinating
Yes,
too.
thank you.
According to Google, Earth was formed 4.54 billion years ago. Life first appeared on Earth 4.28 billion years ago. And soon after ocean formation, 4.4 billion years ago. So they're all connected. Also, there was an article in the recent Science News where they found the building blocks of DNA, uracil, guanine, cytosine, and whatever the other one is, adenine, on meteorites.
Yes.
They found them on meteorites. So, you know, the implication is that the building blocks for life are widespread in the universe, although, you know, we don't know that, but there's some evidence for that at this point.
Yeah. What that article didn't say, Bob, that I wondered about is whether or not those early meteorites or even recent meteorites have been handled carefully by humans.
Oh.
That was in a sterile environment.
Details.
An excellent point.
But that was, they didn't address that. Maybe not.
Well,
Yeah.
the big whack also explains because the moon apparently condensed out of vaporized dust that occurred with the collision, and it explains why the composition of the moon is so very similar to the Earth.
Mm-hmm. Something that fascinates me that I don't know a thing about, except that it has reported to be happened, is the reversal of the poles and the consequences of that if it happens during the human presence on Earth.
Well, they found evidence for that in the clay from fires of the Aborigines. So it has happened within, you know, tens of thousands of years. It's not something that's, and it's happened frequently, actually.
Yeah.
If I could mention something about the switching of the poles, one of the areas I worked in was chaos theory. And there has been evidence that the switching of the poles was a rather chaotic event. And generally it's been attributed to large currents within the center of the Earth, and basically like a dynamo. And every so often the dynamo flips around, the currents go the other way, and therefore the magnetic field generated by those currents then changes, and the North Pole becomes the South Pole, or vice versa. So there is a theory on the switching of the poles based on a dynamo model in nonlinear dynamics or chaos theory.
It would be chaotic, I think.
It is. Yes. And it's true, they have found evidence through fossils and as to when the poles switch. So the pole, the magnetic effect has to do with electromagnetic effects and not angular momentum. So.
So this brings to mind, Frank, a little thing much closer to home. I understand if an electric motor stops, next time you start it, it goes in the opposite direction. unless it has some special thing in it to make it go the right direction. So I always think of this when I start my microwave because it always goes in the right direction. Is this a DC motor or an AC motor? Or am I up the creek?
It would be a DC motor.
Yeah, you can have chaotic effects in motors depending on, I mean, there's all kinds of, synchronous and DC motors. So there's a whole range of them, and it depends what your starting mechanism is. So it is possible for electromagnetic devices to exhibit chaotic dynamics.
It's a casual observation on my part that I haven't pursued, but it's my impression that each time I start my microwave, it rotates in the opposite direction. The turntable does.
Oh, really?
Yeah, same here.
Oh,
Well,
maybe my microwave does that then. I don't know.
Yeah.
That's probably because it's a DC motor.
Ah.
So Frank, why does the magnetic field switch 180 degrees and not just slowly go randomly? Seems to switch 180 degrees and switch 180 degrees back. Why is that?
Well, in the particular model, there's the idea of equilibrium states. So either the rotating currents want to sit north to south or south to north, and the middle is unstable. So if the currents are between the poles, it's an unstable position. So it wants to go in either direction. So it's the same with the pendulum. You can make a pendulum if you allow the pendulum to go completely 360 degrees. The top position is unstable, and the bottom position is stable. So if you let it find its own equilibrium, it will generally pull to the bottom position. But if you have some energy that's vibrating it a little bit, it's possible for the pendulum to go clockwise or counterclockwise and not settle at the equilibrium. So the same with electromagnetic models. There's equilibria, and that's where it's going to try to go to.
So why is the magnetic north not identical with the geographic north?
Because the Earth is tilted.
This assumes that there's a whole dynamic going on in the center of the Earth, where you have massive electric currents, and these electric currents create their own magnetic field and interact with one another. So it's the same problem with fusion machines. Why don't we have fusion machines? Because especially something called a tokamak, in which you have electric currents running through the plasma. They're very unstable, and it's very difficult to control them. So there's similar phenomena going on in the center of the Earth.
How long does it take for the poles to reverse if they do, and what's the effect if you're it's June 21st and you're here in Ithaca, New York?
I forget. By the way, there's no fixed period for when it switches. It's a chaotic event, and I don't know where the mean. It's certainly many centuries. So
yeah, the compass wouldn't work the same way. That's for sure.
Yeah,
it would work, but it wouldn't look right.
Just work backwards.
my simplistic mind always thought it was just the fact of the rotating iron within the core of the Earth that was generating magnetic fields similar to, spinning a magnet in a set of wires or whatever.
Yeah, well, ferromagnetic materials are one source of magnetic fields, but the other source is electric currents that move, and the dynamo theory is the current theory about the switch of the creating of the Earth's magnetic field.
Okay.
I know from cartography and from using maps, your compass is pointing to magnetic north, up near the Arctic Circle somewhere.
Yeah.
And so as you move east or west, there are printed on USGS topographic maps the adjustment you have to make to your compass to correspond to map north if you want to use it for navigation and orientation.
So what do we know about birds? And we know that one of their tools of navigation and migration and so on is magnetic fields. So is there anything that ornithologists have found in the bird history that relates to a flip-flop of the magnetic field of the Earth?
Not that I'm aware of, but where birds' brains have been analyzed and where monarch butterfly brains have been analyzed, there are magnetic particles or iron particles that respond to magnetism. They don't yet have an idea that I've seen how birds might use that for orientation during migration. But the critters that we know that migrate north-south do have iron particles scattered about the brains or some part of the body.
And those iron particles presumably lead them on.
Possibly so, or at least give them the idea that, as I've read it, but not recently, is that there are multiple systems used in navigation and orientation in birds, and that some of them may have priority and others are backup systems, but how they work in concert with each other, as far as I know, isn't very well.
I would suggest the backup system being if the birds start to fly south and it starts getting colder and colder and colder, they go, oops, they turn around 180 degrees and head to the new south.
Yeah, it would appear what they speculate is that the primary mechanism for orientation navigation is actually positions of things like the North Star and other things, celestial navigation. So birds understand where they were raised, the pattern of the skies, and as that pattern changes, they probably orient toward the Polaris, which doesn't change position in some way or another. The sun may be important. Ultraviolet radiation for honeybees is important, may be important in birds. And so a lot of the research with birds was done right here at Cornell by Bill Keaton with pigeons and how they orient themselves, and Charles Walcott after Bill Keaton, and Steve Emlin did some great work on celestial navigation by putting indigo buntings in cages inside planetaria that can be manipulated to change the sky. And the sky being changed, the birds would adjust to the southern sky and detect. And if you changed it so that south was north and north was south, they would orient relative to that change. So they were using celestial cues in some way. And it's just, to me, it's fascinating. And it's fascinating to think about monarch butterflies moving from here to Mexico and then returning partway back in the spring. It's great to think about.
Yeah. Well, what's also fascinating is to be here at City Club with all of the multitude of disciplines that are representative here. We're all looking at the same problem using different tools, and it's remarkably refreshing. So I'm going to go ahead and stop the recording now. I think the discussion afterwards is as much fun as the facts.
I think it's just reflective of the breadth of intellect of this group.
Thank you, Charlie.
Thank you, Charlie.
You're very welcome. Thank you.
I'll add one other thing. My